For today's notes, you'll need in class 54. This is part 1 of standard 13, where we are going to learn about right triangle trigonometry. Sometimes teachers will abbreviate the word trigonometry as just trig. So if you hear that, they're talking about the same thing. The goal of the lesson today is to introduce a lot of the vocabulary and the terminology that you'll need in order to be successful at using trigonometry to solve problems. So, the three main ideas for our trigonometry unit are focused on these three ratios: the sine ratio, the cosine ratio, and the tangent ratio. Sine is abbreviated as SIN, but we still say sine. Cosine is abbreviated as COS, but we still say cosine. And tangent is abbreviated TAN, but we still say tangent when we see that. So the way that these ratios are set up is that they require an angle. That's what this theta is equal to. That is a Greek letter, THETA is how you would spell that, theta. We use that as the variable for an angle. Cosine of theta, tangent of theta. So all three of our trig ratios require an angle as an input, and then what they equal is a ratio of sides. So for sine, opposite over hypotenuse; for cosine, adjacent over hypotenuse; and for tangent, opposite over adjacent. And so what's happening is this theta that we're talking about is actually what we call the reference angle. And so that's the angle that we use when we're trying to make decisions about which part of a triangle is the opposite, which part of the triangle is the adjacent. We don't use the reference angle when we're making a decision on the hypotenuse. We know that the hypotenuse is always across from the right angle. So that terminology should be familiar to you from our Pythagorean theorem days or from our congruent triangle HL hypotenuse leg days. But the others, opposite and adjacent, will depend on which angle of the triangle is our reference angle. That's why in these descriptions, they're asking us for the opposite leg to angle A. This is our reference angle. So when our reference angle is angle A, that means we set ourselves up at angle A, we pretend we're standing there, and then we think about which side would be opposite where we are. So not one of the two sides that is forming angle A, but the one that's on the opposite side of the shape. So for this situation, we would be talking about segment CB. If we go through our options, right there, number 5 is segment CB, just with the letters backwards. So this would match with option number 5 from our list. If we're going to think about the sine ratio of angle C, our reference angle will change. So let's hold off on that one for right now. Opposite angle to side AB. Well, we could probably figure that one out. If we're over here at side AB, we use a different color. That's connected to angle A and angle B, so the opposite angle would be angle C. That's going to be option 3 in our list. We said the hypotenuse is always opposite the right angle, across from the right angle. So that's going to be this third side here, AC. That's option 6 in our list. Here's another one that uses reference angle A, so we can go back to our little smiley face. The adjacent leg to angle A. Adjacent means next to. This next to side for angle A already has a name, the hypotenuse. So when we're talking adjacent, we're talking about the leg, the part of the right angle, the side of angle A that is not the hypotenuse. So that would be segment AB or option number 4. Tangent ratio again switches our reference angle up on us, so let's stop. Let's not do that one quite yet. This one asks us about a reference angle, so we'll come back to that one. H is the adjacent leg to angle C again, so that's a different reference angle. Let's tackle I, the cosine ratio of angle A. So we're going to be able to keep using this as our reference angle. A quick check at the top says that if we're doing the cosine of an angle, in this case angle A, it's going to equal the adjacent side over the hypotenuse. So if we're at angle A, we just said the adjacent side was AB, so that would be on top. And then the hypotenuse was AC. That would be on the bottom. So we're looking for one of these fractions over here, these ratios, that has AB over AC. And I think that matches number 8 perfectly. So number 8 is going to be the cosine ratio for angle A. The longest side of the triangle is always the hypotenuse, so that's going to go back and use AC, or option 6, a second time. And then we've got a couple of different, or one more place where we're going to look for a reference angle. All right, I think at this point in time, the best thing to do is to go back and tackle the ones that have to do with angle C. So I'm going to change my color. I'm going to put a green smiley face here at angle C for our reference angle. This one is asking me for the sine ratio. So if I go check out my information at the top, the sine of theta is supposed to be the opposite side over the hypotenuse. So if this angle C is our new reference angle, the opposite side is going to be away from angle C, between A and B. So that will be the numerator. And then the hypotenuse, back to that same AC side, is going to be the denominator. So I'm going to use that same option number 8 that I already used earlier. So that brings up an interesting point. The sine ratio of angle C and the cosine ratio of angle A are actually the same thing. Something to keep in mind. All right, next up, still with angle C, we're down here at letter F, the tangent ratio of angle C. Let's go check out what they're telling us about tangent. The tangent of C is going to be the opposite side over the adjacent side. So if we come look at our picture, angle C is here. The opposite side would be that pink highlighted one. So AB would be the numerator again. But this time we want the adjacent side, so the side right next to angle C that's not the hypotenuse. In other words, this one right here, BC or CB, to be the denominator. I think that's going to match best, with option number 10 down here. AB over BC is the tangent ratio for angle C. One more that has to do with just angle C, and then we'll go back to these ones right here that have reference angle questions. The adjacent leg to angle C. So back to that reference angle C. This side of angle C already has a name. It's the hypotenuse. So that means this one right here is the adjacent leg. Segment CB or BC, right there, is going to match with option 5. Okay. These other two are going to require a little bit of a different way of thinking. So when we're thinking about BC over AC as being cosine, cosine is supposed to be adjacent over hypotenuse. This matches up. AC, hypotenuse, we knew AC was the hypotenuse, so that's not going to be very helpful in identifying the reference angle. But thinking about how BC is required to be the adjacent absolutely will help us to choose. If BC needs to be the adjacent side, that means that C has to be the reference angle. We couldn't use A as the reference angle because then BC wouldn't be adjacent. We don't use our right angle as a reference angle. It's always going to be one of the two acute angles. So if BC is the adjacent side, angle C, or option 3, must be the reference angle. All right, one more. We've got the same ratio, but this time they want to know the reference angle if this is the sine ratio. So if we peek back up at the top, sine is supposed to be opposite over hypotenuse. So again, that denominator doesn't help us, but if we think about BC as being the opposite side, now that forces me to use angle A as my reference angle, because then BC would be on the opposite side of that triangle. Angle A is option 1. Okay, so all of that matching is just there to give us a chance to get used to a lot of the vocabulary. What we're really going to be focusing on is this second section here, where we're looking at the types of problems that we're eventually going to learn how to solve. For right now, though, our focus is not on solving. Our focus is on labeling we're going to use the given reference angle that's labeled with a degree measure. So in this triangle right here, that 30-degree angle is going to be our reference angle, versus in part B, the 63 will be our reference angle. And we're going to put 3 letters on the picture. O for the side that's opposite, A for the side that's adjacent, and then H for the hypotenuse. And then once we get those labeled, we'll come back and we'll make some decisions. So for right now, let's just practice our labeling on all 6 of these pictures. If we set ourselves up at this 30-degree angle, we travel to the opposite side of the shape. That will be our opposite side. If we are at the 90-degree angle and travel to the opposite side of the shape, that's the hypotenuse. So then process of elimination, this side right here, that's part of the 30-degree angle, will be the adjacent side. Sometimes people prefer to start with the 90-degree angle and get the hypotenuse labeled first. So let's try that for part B. On the opposite side of the shape to the 90 is where the hypotenuse is at. Then they go to their reference angle. The other part of the angle that's right next to where they are is the adjacent, and the one that's on the other side of the triangle, opposite, is the opposite. Right angle sends me over to the hypotenuse. My reference angle is over here with the 13. So the other side connected to the 13 is the adjacent side, and then the last side that's over on the other side of the triangle is the opposite. Go ahead and pause the video real quick and try to label your sides for these last 3 examples, and then we'll come back and we'll see how you did. All right, hopefully you found success. Over here would be hypotenuse opposite the 90. This is our reference angle, so 12 is opposite, and then this empty side between C and B is the adjacent. For this triangle, the 90-degree angle is on top, so the hypotenuse is between C and A. Your reference angle is here, so that 18 would be the adjacent side, the other side of angle A, the reference, and then the opposite side would be the X. Last but not least, in the last one, we've got our right angle. So across from there is going to be the hypotenuse. Our reference angle is right here at C. So the top side of that shape is the adjacent, the other part of angle that's 35. And then on the other side of the shape from the 35, we've got our opposite. All right, now that we've got that taken care of, we're going to come back and choose part 2 here. Which trigonometric ratio should be used to solve for the missing side marked with the X? So we're not learning how to solve yet, but we're trying to pick which one of these sine, cosine, tangent ratios fits each of these situations the best. And the way that we do that is by ignoring the label that doesn't have any other information related to it. So when I look at this shape, I see the hypotenuse is 12 and I see the opposite is X. I don't see anything labeled on the adjacent side, so we get rid of the adjacent. That's not a good focus for us. And then we think about which of these 3 ratios up top, where you can see the little equation set up, would use both the hypotenuse and the opposite. That happens in the very first one. Sine of theta is equal to opposite over hypotenuse. So sine is the best choice for this triangle. Moving to the next one, I see the hypotenuse is 34 and the adjacent is X, so that means this time around opposite is not known or needed to be known. So I'm looking for which of these 3 ratios uses the hypotenuse and the adjacent. Not the sine, because that would be opposite over hypotenuse, but if I check the middle equation out, it says cosine of theta equals adjacent over hypotenuse. So for this one, cosine is the best fit. For the final example in this row, I see my opposite labeled with an X and my adjacent labeled with a 25. So for this one, the hypotenuse is out. If you go check your ratios up at the top, sine would use opposite and hypotenuse, so that's no good. Cosine would use adjacent and hypotenuse, so that's no good. So tangent must be the choice, and sure enough, if we check that ratio out at the top, it says that I need my opposite and my adjacent, which I have. So tangent would be the choice for that final one. If you'd like to pause and try the next 3 on your own, feel free to do that. come back and check your answers. Otherwise, let's go through these final three. I see the opposite is 12 and the hypotenuse is x, so we're going to avoid the adjacent. Sine is opposite over hypotenuse, so that avoids the adjacent. For question E, I don't know the hypotenuse, so I'm going to avoid that, which means I can't use sine and I can't use cosine, but I could use tangent in order to use opposite and adjacent. Final one, I don't have any information about the opposite side, but I have the hypotenuse and the adjacent. Sine is opposite over hypotenuse, so that's out. Cosine is adjacent over hypotenuse, which is a perfect fit for what's sitting here. When we do in class 55, we'll talk about how to actually set up and solve those equations so that you can find those missing sides. But for now, we're going to flip to the back side of this page, so I'll meet you back here in just a minute. All right, for the final portion of this introduction set of notes, we are going to focus on two phrases that will help us later on down the road be able to solve application problems that use right triangle trig. These are both related to certain angles that can happen when we're describing situations. So the important thing to know is that both of these are angles that are measured from a horizontal. So an angle of elevation is an angle measured up from a horizontal. Sometimes we call the horizontal a line of sight. It's like we imagine looking straight out from somewhere, and then we would look straight out from that spot and then up for an angle of elevation. For an angle of depression, it's going to be an angle that's measured down from a horizontal. Again, that horizontal might be called a line of sight. Okay, but the key is both of these angles have to be related to a horizontal. So we have a whole crazy picture of a whole bunch of things going on, and then we have a whole bunch of descriptions that are asking us which angle fits the description best. And so the angles are just named conveniently with all of these little numbers. So we'll say angle 8 or angle 19 or angle 10. Okay? So the first one we're looking for is an angle of elevation. So that means we need to be going up from a horizontal. And the horizontal, or the angle, excuse me, has to connect a car to the top of the diner. So if we go find the car, we look out horizontally towards the diner, and then we look up to get to the top of the diner. That's what angle 17 is describing. The next one is an angle of depression, so that's going to be from a horizontal down. It's going to be from the top of the tall building to the diner. So we're going to go to the top of the tall building, look straight out to find the horizontal, and then we're going to look down until we see the top of the diner. So that would be this angle right here, angle number 6. Next up, the angle of elevation. So we're looking for an angle up again from a horizontal, this time connecting the plane to the helicopter. So if we go to the plane, there's a horizontal that's looking out this way toward the helicopter. Then we would go up from there until we find a way to look at the helicopter itself. That would be angle number 4. Part D is asking us for an angle of depression. So that's an angle down from a horizontal. This time it needs to be from the top of the diner to the buoy. So the top of the diner to the buoy would mean the horizontal is facing out this way. We want to go down from the top of the diner until we make it to the buoy. Looks like his feet. That would be right there, angle number 9. Okay, let's do one more together, and then I'm going to have you pause and try to find the others, and then we'll come back and run through the answers real quick. Last one for together, part E, the angle of depression is going to be from a horizontal down, this time from the helicopter to the plane. So if I start going horizontal out from the helicopter, and then I look down along this line of sight to get to the plane, that angle 10 right there is what we trap. All right, go ahead and pause the video, go ahead and fill in what you think all of these others are equal to, and then we'll come back and you can check your answers. All right, as we check our answers, you won't be able to see my answers written out because I want the picture to be able to show up, but I'll try to show you where each of these is at as we go, but just very quickly. For F, it's the angle of depression from the plane to the top of the diner. So right here from a horizontal down, that would be angle 13. For G, it's the angle of elevation from the boy to the top of the diner. That would be right here, angle number 14. For H, it's the angle of depression from the top of the tall building to the top of the car. This is a little tricky, but this would be the angle we're looking for. So it's going to be called angle 18 because it's that whole angle that puts 6 and 7 together. For I, it's the angle of depression from the helicopter to the top of the tall building. So from that horizontal down would be angle 5. For letter J, it's the angle of elevation up from the top of the diner to the top of the tall building. So top of the diner to the top of the tall building is going to be angle 2 right there. For K, it's the angle of elevation up from the top of the diner to the plane. So the top of the diner up to the plane would be angle 3. For L, the angle of depression down from the top of the diner to the car. So top of the diner to the car would be angle 1. For letter M, the angle of elevation up from the boy to the top or to the front of the plane would be this whole angle here at the bottom, 14 and 15 put together. So we would call that angle 16. 3 to go. For letter N, the angle of elevation from the car to the top of the tall building. So from the car towards the building sends us this way, and then we want to go up to the top. So that would be angle 23. Letter O, the angle of depression down from the front of the plane to the boy. So the front of the plane has all these angles attached, but to look at the boy, we actually look backwards from the front and then come down to be able to see the boy. That's this angle 21. It's kind of hiding below the plane. And then last but not least, we need the angle of elevation from the tall building to the helicopter. So if we're at the top of the tall building and we go straight out and then look up to the helicopter, that would be angle 11 right there at the top. All right, that's it for today. Bring these notes back with you, and tomorrow we'll learn how to use them to start solving for some missing sides.